Our last panel is a star-studded panel with several of the leaders of our aviation industry are here to discuss our industry's plan for looking forward and ensuring that we are enhancing safety in the future through data analytics and technology. I, for one, have definitely been waiting for this panel. Please welcome the ASO Safety Chair, Captain Steve Jangelis, and panelists to the stage.
Hello, hello, hello. Hello, hello. All right. Grab a chair. Well, good afternoon, everyone. Again, as Stacy said, thank you for the kind introduction. This is the last panel of the 67th Air Safety Forum. Again, my name is Steve Jangelis, the Aviation Safety Chair, and it is my pleasure to bring along some giants in the industry today to talk about what's going on in the future. We're all moving forward together. That's the theme of this event. And we've been talking about what's happening today with security and other issues and pilot assistance, but brought this panel together to talk about what do we see, what's going to be in front of us as we move forward in safety. So joining me today on the stage is manufacturers, airlines, the regulator, some data managers, and NASA future scientists. So I'm really excited to kick this off and get this going. So I'll start off with, to my left is Dr. Kirk Vining, Chief Pilot for Product Development at Boeing. Captain Craig Hoskins, Vice President of Safety, Security, and Technical Affairs of Airbus Americas. We've got Ms. Sasha Johnson, Vice President Corporate Safety for United Airlines. Ms. Kimberly Pyle, Federal Aviation Administration Executive Director of the Office of Accident Investigation and Prevention. Mr. Kyle Quakenbush, Lead Aviation System Engineer for the MITRE Corporation. And Dr. Nikunj Oza, NASA Leader of the Data Science Group. Well, I take a look at what we have on board our aircraft today, and as I look towards our manufacturers from Airbus and Boeing, what type of new data streams are your aircraft capturing, and are you leveraging any of that in the design, maintenance, and ongoing training of your employees and the pilots who may fly them? What kind of things can we see as pilots going forward?
Right, of course data is growing. It's within Boeing, we have organizations and directors setting up around data. As a manufacturer, a lot of that is oriented towards the production and manufacturing system. But we are harnessing data and experimenting new ways. So I'm the Director of Research Flight Test, and I'll talk a little bit about in June, we did a test on a 787 where we were bringing in data using broadband and internet protocol. So this would, in a sense, replace the ACARS channels and CPDLC on an internet protocol. There's more data, there's more secure. And what we did with this test is we worked with the air navigation service providers, Singapore, FAA, Japan, and in Thailand. And they were able to connect together because it was an internet-based protocol. And as pilots, what we saw is an actual display on the airplane, on our iPad, and we could watch this communication happening and watch the trajectory being worked and modified and our clearance going through. So that's an application of data that could, in the future, come forward that we would see in the flight deck.
Excellent, excellent. Craig?
Thank you. I can echo that. So some of the data that streams that we're using, of course, we look at, the design and always improving. And it's interesting, when we as pilots, when we think of simulators, we think of the full flight simulator. And, we have a set, I'm sure like Boeing does too, engineering sims that are fixed, and you can actually move, set up different scenarios of what kind of data that you can get off the engineering sim before you take it to the airplane for full flight test. And which is very key with that. So much like that, you think about, where we were, years ago, and I've often said, when I was at Northwest Airlines, I flew the DC-9. There was not much of a data stream on the DC-9. And, you think about even where, the Airbus A320 was in 1988 is not where it is today because of the data that we can get off of that. but also and learn from that and then continue the improvements in technology, so which is very key. And also setting it up to where you can get the same feedback so that basically an A320 that you bought or flew in 1988 still feels the same as today, which is key. And I think another thing, Kirk and I were talking about this before the break, when it comes to data and how you can improve, it's the sharing, and not that we want to become a data analysis center. However, it's key on some events, if you will, to have the partnership with our customers. Because a lot of times the feedback or the data that we get from our customers is normally reactive after an event. And what would be key is having some of that data coming in before an event where it's proactive, so that when we make changes or make different changes in the technology, having the feedback from the customer is very key as well. So,
most importantly, you know, we being at the front of the flight deck, some of this data that we don't know anything about is being beamed down, and obviously there's concerns about cybersecurity, protection of that data, and trust of that data. And you know, we appreciate being able to meet with you and talk with you about that. Let's talk about the really cool pilot stuff that you're doing with your aircraft. Real quick, as a follow-up question, Kirk, some of the things you've laid out to our aircraft design organization group operations group has been amazing. So just a couple tidbits, maybe just some nibbles of what you're working on there.
Thanks for the freebie there. So every year we have an eco demonstrator project. It's a different airplane every year. We pick an airplane depending on what we need to check, but we'll try new aerodynamics, new materials. For example, shape memory alloys. These are metals that'll remember one shape, and you change temperature and it goes to a different shape. So we tried out some vortex generators on those. So, but the Boeing focus on safety, what technologies can we bring that would help the pilots do their job efficiently and safely? And then the sustainability aspect. We're all looking at 2050 as a carbon neutral goal. And the thing that we have to watch out for as directing flight test, engineers can come up with great ideas to improve sustainability, reduce noise. And I was telling Steve, I just had a conversation just 2 days ago. An engineer said, hey, why don't we try a flaps 15 landing in a 15-knot tailwind and on steep approach? That would be really quiet. And I said, yeah, but I think the noise of the fuse plugs, tires blowing at the end is going to negate that. So yeah, we have to have that balance. Yes, we are looking for sustainability, but even in the test world, before it even goes out to you, we have to understand how that might eat into safety margins.
Great, and you know, Craig, I was just out in Toulouse last week and visited the factory out there. I know there's a lot of work being done in your building. Maybe some tidbits on what's coming up.
So you think about, you know, I'm going to come back to that first analogy, you know, with the 320 in 1988 and where it is today. If we didn't continue to make the aircraft more resilient, we'd still be delivering a 1988 aircraft. You know, and you know the engineering that goes behind it, the testing, and a couple of cool things that we're doing. A big leap was during the A380 program, and then taking that one step further on the A350 program. And some of the items that are coming out, you know, with the A350, for example. Autopilot, you know, flight director TCAS, you know, where you can get a resolution advisory and the autopilot flies it, or keeps the flight directors on. Other technologies as well in making the aircraft more resilient is the minute there would be a non-normal, if you will, you lost the autopilot. Well, that's about the time you really would like the autopilot to reduce the workload. So that's underway. We've got another program that's taking place. It's called Dragonfly, and we're working with some business partners. And basically, it's pretty cool in that if the pilots became incapacitated or whatever, the aircraft would actually divert and descend and avoid restricted areas and weather and land if there was full incapacitation of the flight crew. So those are some of the things that we're working on as well.
Great. No, it's definitely, like I say, I came out eyes wide open about what's going on out there and the same when I visited Seattle. There's just a lot of project work, and the manufacturers are leading the way, obviously with the customer in mind on that. My next question goes on to Sasha. what are you doing today with these data streams that we're getting from these aircraft and this technology, and how is that benefiting your operational safety, training, and efficiency at United?
Yeah, so I mean, I think it's really important when we talk about data that everybody here know how much governance goes into that, right? We don't just sort of say we're going to collect data streams and not know how we're going to use them, how we're going to analyze it, but also how we're going to manage all the protections that go around the data that so many people in this room care about. And I would say, you know, in corporate safety, I have the real privilege of getting to see the entire operation. So not just the flight safety side, but I get to see the ground side, the maintenance side. And so we're doing a lot of different things using data to improve just operational safety generally. I mean, one of the things that might not be as germane to this audience, but that's really important for the industry, you know, we're using new technology to figure out how to better prevent heat illness amongst our operational employees on the ground, for example. And there's a lot of data we're collecting around microclimates to figure out how to keep our employees safe as, you know, climates change and summers become warmer. So that's a data stream that we're managing. Obviously, we're using sensor technology. We're testing some sensor technology to try to reduce aircraft damages. That's another set of data that we need to figure out how to integrate into United's system. And we're certainly looking at AI and doing all of that work from an innovation perspective. But I think that the real place that we're focusing on data is that integration, because we can get all of these independent streams of data, but if we don't know how to manage them, if they're not governed correctly, if we're not integrating them, then they're not as effective as they could be. So we've taken, I would say, kind of a back to basics approach at United, especially with our safety data, because I'm sure other operators here would know, and Kim knows from the FAA, you know, sometimes safety data is pretty siloed. And the quality of the data can be different depending on how it's collected. So one of the core things that we've done at United is we've undertaken an enterprise-wide effort to standardize how we do root cause analysis. Because if we're not getting good data, then whether we can trend it or not or integrate it or not is not really going to be that effective. And to credit to the FAA, that's been a huge focus for them, especially from a regulatory compliance perspective, to ensure that we actually understand why something's happening. And so we're going through and doing that right now. We're also looking at new data streams. So as we grow, we need to figure out how to manage our threats and identify errors. So, you know, others in this audience have already embarked on this, but we are starting continuous LOSA. And so figuring out how we bring that data in, we've got a governance committee around that, what we do with it, how it gets fed back into training, how standards evaluates that, how flight safety looks at that. And then we have a different, you know, set of myriad of ways where we can go out and share that data with our flight crews. And that, to me, is going to be a real rich data set and an opportunity where we can go out and actually target risks that we're seeing developing in the system, going out and validating issues that are coming through our voluntary reporting program. So that is a new set of data that we're going to be bringing in to the safety space. And I would also say that, you know, when I think about the data that we are getting, voluntary reporting programs is one where I've been spending a lot of my time focused on, because my team manages the programs across the operation, not just on the flight side. And so I think, you know, historically we've looked at those programs by operating group. I mean, we'll look across the system and look for trends, but we haven't really factored in other data sets or other data streams that we could bring in that could perhaps give us a richer picture of the risks that are perhaps or the hazards that are being identified through those programs. And so we've undertaken a new project thanks to the leadership and partnership with ALPA and our flight ops team and our flight safety team, where we're looking at our voluntary reporting programs a little bit differently. We took 2 years, and this is an initial project, so it's getting more mature, but we took 2 years of pilot voluntary safety reports and actually integrated it with pilot experience and proficiency data. And obviously, we looked at that at an aggregate level. But the reason that we wanted to do it is because as the industry has realigned, as we've brought new pilots into United, as people have changed seats, what are the different risks and issues that are being reported through our voluntary reporting programs based on experience? And so we've seen some interesting things. I think we'll see more as we get more mature with the process. But you know, we've sort of cut the threshold right now at 500 hours as part of this project, because 500 hours represents about a year in a seat. So you know, what issues are presenting themselves based on experience level. And it's not only to kind of the person, but it's also to the crew pairing. So if you have a pilot captain with over 500 hours and an FO with less, what are you seeing when they come together? What are they reporting? Are there commonalities? Are there trends that we need to be considering? And so as it gets more mature, I think that we'll be able to take some of that data and perhaps work it back into training. But as it becomes more dynamic, I think the richer opportunity is for us to use it for safety promotion. If we see a consistent set of issues, can we go out and, ideally it would be to go out and say to those crews in that pairing, hey, we've noticed these things in your threat forward briefing, please talk about these things. Because sometimes I think we fall into this idea that we can only reach people through training. Obviously that's very important, and that needs to be dynamically looked at and evaluated, but we have other ways through safety promotion to get that data to our crews to enhance safety. So I would say that as we continue to move forward and continue to grow, that data of voluntary reporting is one that I'm primarily focused on. And credit to the folks in this room, I mean, the pilots have matured that reporting process. Where we need to continue to work is with the other operating groups in the industry. So I constantly ask United pilots to be leaders, to go out and have them talk to maintenance technicians who are doing walkarounds, talk to them about why it's important to report. Because we need to see the hazards that they are seeing. They need to report so we can then put that in the system. And as we get more experienced and proficient with integration, we can hopefully better identify those risks.
That's great, because you're looking beyond just what are the data points that are coming in. You're trying to compare it with those experience levels, and that's a big key. Not just saying we had an incident, let's react. Let's see if maybe those experience levels, or maybe there's a precursor to it that we could maybe get into training, get the risk, like you say, discuss it in a briefing prior, so that we're aware of it. And I think that's the tool that pilots are really looking for, is the ability to identify the risk and then mitigate it on the fly in the actionable sequence of flying the aircraft.
Right.
So really, really good stuff. And as we were talking in the circles about the data that comes off of the aircraft and then what the airline does with it, and then, okay, so who owns that data? It's all based on contractual ability here with our labor unit. The manufacturer builds an aircraft for an airline who purchases it, and then the airline chooses how they want to use that data and go with it. And so we, as the labor partner, want to be a part of that, and it's all based on trust and just culture. And if we see precursors out there, we definitely want to be partners in this. But I really like that idea about the experience levels, taking a look at it. So really, really good stuff there, Sasha.
Yeah, one other thing I would just add too, where we see a real rich opportunity around that data integration, is the issue of turbulence. Because if you just look at weather and injuries, you're never going to figure out why something happened. So we have a big project underway, which will take time, where we're pulling, pilot reports, determining when dispatch was aware of turbulence, determining when pilots were notified, when pilots told dispatch. We need to understand all the different pieces of how we, our fleet mix, how we route aircraft, the weather. Obviously, the injuries get factored into that, but we need to see the full picture of all the elements of turbulence, not just the event itself, everything that led up to it. And then that will help us better inform policy decisions if there's processes we need to change. And so, that's where we see, as we go forward, the real power of that data is solving, or at least mitigating, some of those sort of persistent safety risks that the entire industry is dealing with.
And there are technology tools for that as well, which the airline is providing.
And another data stream.
And another data
Off
stream,
the aircraft.
exactly. Off the aircraft, the iPad, the products that are out there, and the issue is we've got larger airlines. I'm a Delta pilot, United. We're a larger airline. It's trying to roll that information out to our smaller airlines, our general aviation partners, and we all win with that, especially in the turbulence mode, because I know, speaking with Kim, it has been a busy year for turbulence incidents out there. And how does the FAA play a part in data collection, dissemination, and analytics to ensure people don't get injured by things like turbulence or other hazards that are out there?
Well, normally we're really conservative with a lot of things, especially because we're really trying to be a guardian of safety and the legacy system. So we also have to be a guardian of the trust that you have given to us. And so we're a little bit slower to move. That being said, we are doing research into AI capabilities For example, the same kind of natural language processing tool that ChatGPT uses, we have that, that coding running on NTSB reports and ASRS reports in a controlled environment, a controlled body of knowledge that's feeding this code. And we're able to populate fault tree analysis from that code in seconds. And so there's potential here. And once we get that capability right, I think there's potential to understand what is happening in the system today that is making us so safe. And what is the quality of the controls that are existing? Because as we add these new entrants, these emerging entrants into this incredibly safe airspace, we don't do that in a cavalier manner. You know, we're like, that's great that you can do all this really neat stuff. Prove it to us first. But in order to even have comfort letting some untested technology test themselves, we have to understand how the current controls protect the rest of the system. And so are the controls working as designed? And that's why I'm excited to hear about the things that you guys are doing and the integration and the data sets that are coming off the plane. I would like all of that data now, please. Now, I think it would be great if we could have access to it, but it's going to take some time, right? And it's going to take building trust, and it's going to be working with partners like ALPA to conduct and draft the right governance to allow for that exploration in safe areas. And I think there's a lot of potential here. There's also a lot of risk. So we are very risk averse at the FAA. We are very slow to accept risk. And I think that's probably good. That's a nice balance, right? You have to have innovators. You have to have new ideas coming forward and evolving the system. We also have to balance that a little bit with the protectionism that we do when it comes to making sure that legacy air traffic system and pilots are still as safe as they were, 10 years ago. Or not 10 years, 5 years ago. Let's go with 5 years ago. It's been pretty good for the last 5 years.
Perfect. Kim, you and I were in a meeting, 2 weeks ago, where we were meeting with some of the new entrants that are coming into the industry that want to fly wherever they want, whenever they want, with flying boxes, flying, passengers without a pilot. It was an interesting forum. And what do they want? They want the FAA to just allow it all to happen. Yeah. Don't worry. We'll collect data as we do it. And I'm appreciative of the fact that the FAA stands up and says, well, wait a minute. You can operate in this box over here, but you can't just fully integrate. Because the argument they give you is that we would like to practice in the arena we're going to fly in. Now, it doesn't sit well with us. Right. Personally, because we don't want to be operating. I don't want to put anyone here, friends or family, on an aircraft that's going to be operating with a experimental vehicle so that they could collect data to sell their product. That's unsad in our eyes. And so I appreciate the FAA's approach to being, with all of the new entrants that are coming into our airspace, being very cautious, analytic, and collecting the data in a segmented, protected airspace. And that's great. So, Kim, we've been going through discussing, Craig is the Commercial Aviation Safety Team co-chair. I am the ASIAS co-chair. Can you tell us a little bit about what we're doing with those projects and programs on taking data, ASAP reports, FOCO information, LOSA, all that information coming into the FAA and to the industry? What are we doing to try to do better with it, change it up?
Yeah, we're actually spending a lot of time, and all of these folks on this stage just about are involved in the evolution of CAST and ASIAS. We'll be having a new platform to process the data that's going to be coming out. And in the meantime, MITRE's been doing an incredible job leaning in at how can we expedite data analysis. Because we know we don't want to wait 6 months to find out why something went wrong. We certainly don't want to wait 2 years. So we have to get as much information as we can that's reliable and trustworthy and understood to start making change right away. So we're working on governance that will allow for that capability development in a controlled space, very much like we control all these new entrants. We control the space, the sandbox that we're practicing in. We're we're engaging each other in a more dialogue and discussion and really leaning into having robust conversations about safety at every meeting. And I think that was Craig's idea, to really lean in and have a dialogue instead of you know, what we traditionally do, which is look at data that the great guys in GymDat and the gals in GymDat will bring to us. And really what is important is the actions that we take as a result of that data. So once we see the data, what do we do with it? And how does that influence our decision making at our own organization? So how does it influence decision making at FAA or at United Airlines? And so those are the discussions now that we're having, and it's really encouraging. I think we're going to keep leaning in with the SIAS to see how many data streams we can safely integrate and bring in and protect, because data protection is #1 for all of this, for creating that just culture environment that is foundational for safety.
And that's, you know, I'll tell you, that's some great stuff, because I think some of the best part of the job is being able to work with people on this stage here in that arena, trying to figure out, like you say, the governance. What do we do with the data? Where do we get it? Some of our older reports we're seeing this many ASAP reports system-wide. What do we do with them? Where do we go with it? How do we leverage that? And so now we're getting into that predictive risk model, which is important and imperative moving forward. So, you know, stay tuned. Please do, absolutely.
So I think you mentioned kind of awareness around voluntary reporting, and you know, I think this innovation is remarkable, but we never want to lose sight of, and I've said this before, about kind of getting back to those basics when it comes to safety. And that's something that we've really tried to do at United, is to raise awareness for leaders about the issues that are coming up through the program. Because, you know, they need to know what's happening at Chicago, you know, what reports have come in. So we've built dashboards. We're now sharing, again, that aggregated data. Here's the issues that are rising. But it's also really important that we share the wins that come out of those programs, and that's part of the data that we're showing back, because that's what's going to drive more participation from, you know, across the operation, across the industry, if people see that organizations are actually actioning that data, which I think is hugely important.
I have to applaud you, because as we spoke in the pre-brief room, you rode the jump seat out here. So I'm glad you were able to get up front and sit with the crews and see what we go through, and how that data may, you know, you might influence some decision making at the executive level. So thank you for doing that. I wish we could get all the executives on our jump seats to see what we do. You want to go, Kim?
I want to go. Yeah, no, I mean, I want to ride the jump seat on the way back. Thank you.
Okay. Well, you're with the FAA. I'll buy you a ticket home. I'll buy you a ticket home. How about that?
Kim, but, yeah.
I'll buy you a ticket home, Kim.
Yeah.
I'm sure whoever that crew is going to thank me.
She's flying United, so I'm sure.
Oh, we'll narrow it down, yes. From the FAA, and I'm here to help. Anyway. My next question is over to Kyle. Kyle, we talked about it. Kyle, you work for the MITRE Corporation. About 97% of what the MITRE Corporation does, we can't talk about. But the 3% we can talk about is the aviation portfolio. And, you know, could you tell me what new technologies MITRE's working with to enhance our data analytics and in turn improve safety, turning back to the industry?
Yeah, absolutely. And first off, thank you to ALPA, to you, Steve, for inviting me to participate on this panel. A lot of enthusiastic leadership up here, and it's an absolute honor to be a part of it. So the MITRE Corporation, as the trusted third party for the SIAS program, we're currently actively working both with government and industry to identify a strategy, or really an AI strategy, that is going to position the program to be a leader in the application of those machine learning concepts and capabilities. So more specifically today, we have leveraged some basic concepts, machine learning concepts, and capabilities that allow the human to interact, understand, organize the information in the data to otherwise pull out potential hazards or risks that aren't otherwise known to just somebody looking at the information. We forecast out our FOQA metrics, and we monitor those and look for unexpected results within the FOQA data, and that kind of leads us to identify potential new hotspots within the system. We do apply some natural language processing models, and that kind of helps us bring forward the narratives of those safety reports that might be anomalous or we would consider anomalous. So we use these basic kind of concepts, but we're looking to turn that corner to put together a methodical, collaborative based approach in our current public-private partnership that will allow us to, again, position the program to be leaders for the application of machine learning concepts. We recognize we don't necessarily need to be the leader in AI research, but being a leader in the application for aviation safety space and applying that to the aviation safety space domain.
Great.
Yeah.
Great. No, that's good stuff. And without MITRE, with the help of collaborating and collecting this data, you know, you've heard, we've said, and waiting weeks and months is just, that's part of the system. And I appreciate the efforts. And, you know, when we start talking machine learning and AI, I start to go cross-eyed because I still look at my cell phone and wonder why it's doing what it's doing. But, you know, there's some very, very smart people working on some solutions to better collect this data, get it to us quicker,
right,
and to back to the end user, you know, the airlines and ultimately the pilots up front. So thank you for the work and the efforts that you're doing at your corporation. So Nikunj, Dr. Oza, I'd like to turn to you on this. What is NASA doing to assist the industry and the regulator to innovate the collection and analytics of data, and how does the traveling public benefit from the work and further research? You've got a distant horizon out there that you're looking down, and I'm really interested to hear your views on where we're headed.
Yeah, thank you. Yes, certainly thanks for having me here. It's my first time actually at the ALPA Air Safety Forum, so yeah, it's been quite educational for me. I think I'm the only one who has slides this time. I promise I won't do death by PowerPoint here. I like to think that I won't, but to answer your question, Steve, so we really are aimed at, you know, as you said, toward that long term. So we're taking, you know, currently we have this kind of a radar-based, you know, very human-centered, a lot of human grunt work, and we're really trying to use machine learning, other areas of AI in a complementary way because it is complementary to humans. So getting towards the infocentric NAS, which is an FAA vision where it's about allowing for mission services that are tailored to you know, different providers. So we of course have the Part 121, but also the new entrants, as was mentioned, you know, want to be able to, you know, have them get the services that they need to be part of the NAS, to play nice. And then we have a vision called Sky for All, for which, you know, more documentation is also available. But the idea there is aiming towards something that's highly automated, not completely automated, but where it's really meant to use AI to help with handling that complexity, the scalability with the new entrants. And so that's, you know, we're using different technologies like AI, there's Internet of Things, digital mesh, others, you know, to be able to allow for, you know, we talked about all the great variety of data that are coming in, having it be managed and not having people drown in that data, right? You know, because you don't actually really care about the data, you care about information. So let something else handle the data. And we have a project, a system-wide safety project. It's one of the few, maybe the only NASA aeronautics project that's actually supposed to exist in perpetuity because aviation safety is seen as being so important. So of course the project will evolve over time. As shown, there are these different sub-projects, or what we like to call technical challenges. And there are a few different threads to that. So the bottom fork shows design safety. So the idea is, to what extent can we design to or make sure that the system is safe at design time? That really goes to what Kim asked, prove it. The effort of those sub-projects depicted there is to mathematically prove that what you're proposing is going to get a certain guaranteed level of safety. But of course, that's not quite good enough. You know, when you're in operations, the world's a bit different from what you expect, so that's where the top fork comes in, and I've highlighted in orange the sub-project for which I'm one of the leads, which is looking at commercial aviation. So there's machine learning as part of that. I lead a sub-team that develops machine learning algorithms that can make you cross-eyed if you like. But we also have a component that looks at human performance and fatigue, things like pilot schedules, how that impacts fatigue and then therefore performance. And then we have a sub-project called Human Contributions to Safety, which is really aimed at looking for, in the first panel yesterday, it was Captain Secord mentioned, what are those many situations where you don't actually get to a safety event, but something kind of started to go wrong, and a captain recovered. We want to capture that. That's what that component of our project is about. And then kind of towards the right, you see this is more about, as you have new entrants coming in, how we don't have as much data for them, but what can we learn even just given what's already coming online. And then the safety demonstrator series really, I think, goes, Steve, to what you were saying, that you don't want the new entrants coming in and operating in the NAS, kind of, hey, try it, see what happens. We want to demonstrate these things in restricted scenarios. So we've been working on demonstrations in the context of fighting wildfires. There's another one where there is about to start looking at hurricane monitoring. So this is in particular situations away from most traffic and seeing, okay, can we have something working there first before we allow new entrants to come in to the wider NAS. And then there is this emerging sub-project that is meant to encompass a greater variety of data sources. We've already spoken about things like FOQA and the safety reports, but then, and also LOSA was mentioned, but maybe there are other ones available now, maybe other ones will be available in the future. How can we use them in the best way possible? And that is all intended to go from the current safety management system that you see down below, which is a lot of work in data collection, a lot of people pushing data, trying to bring it together, many people working together to actually see what does that data actually tell you, get some useful information out of it. And it's very reactive because it takes a long time. So we want to move towards what you see up above, which is less human intensive on the data collection and aggregation side, using the humans for their domain expertise where it's really needed. So producing visualizations that will help and actually understanding what's going on, not just when an incident happens, but look at any kinds of indications, some problem may be brewing up in the future, some kind of unwholesome trends for which you can proactively maybe set up a mitigation, and then you want to see, did it have the intended effect? Were there some unexpected, undesired effects that happened? Can we actually get that kind of information? So really trying to get more predictive and proactive. So this is just one example, the kind of thing we're trying to look for. It's data-driven anomaly detection. We're given how safe the system is, you can safely assume that an algorithm like any kind that we've developed, if it says that the data is statistically normal, it's probably operationally normal. By the way, this is not to scale, of course, because you wouldn't be able to see what's really operationally anomalous. So yeah, I had to blow that up there. So among the statistically anomalous data, of course, there are going to be known problems, and then there are going to be lots of false alarms. But then we want to look for those few what are unknown or haven't been properly characterized, those kinds of safety issues, and have them actually characterized, set up as exceedances that can be regularly monitored. But now what to do about those false alarms? Now, we could get some of you to come in and label all of those what are found statistically anomalous, but you'd get upset with us pretty quickly. So we are doing research in augmenting anomaly detection with active learning, which is an area of machine learning that respects domain expert time and essentially tries to find what is that key, let's say one example where, I think I messed up here. So what is, if you could just label one example, what is that one that you should review and where we want your insights and that's going to maximally reduce the false alarm rate? And then if you still have time, what's the next flight where if you label it, you're going to give the biggest bang for the buck? And this is to tell us, okay, that statistical anomaly, is it really a safety issue or is it not a big deal at all? So but again, trying to minimize domain expert time, but really using their expertise to help improve what machine learning comes up with. Now, identifying anomalies is great, but we really want to get to identifying the precursors, right, as is depicted by that bottom left arrow. What is that earliest point at which you can say, okay, instead of going as you normally would, heading towards a safe state, you instead are in a state where you have a higher than normal probability, still very low, but higher than normal probability that you're headed towards that hazard state. And what are, in many cases, either the system or actually oftentimes it's a human, actually corrects us and gets us, instead of heading towards that hazard state, it instead gets us towards recovery. An algorithm that we developed in-house, just from some simple tests, seems to show promise in identifying those kinds of, in many cases, human contributions to safety. So, you know, that's another benefit that we have in addition to identifying the precursors, right? We're not treating safety as a binary thing. We're realizing, okay, sometimes you go unsafe, but hey, sometimes the system or the human causes a recovery. We want to capture that. So as far as, you know, what is needed, I think to a great extent this was alluded to by others, but we want to handle multiple types of data, right? We have safety reports, FOQA, et cetera, and we don't just want to put them all in one big pot and stir it and see what it tastes like. Maybe we want to use data in sequence, like certainly we've done things like find anomalies in radar track data and only then pull voice recordings. So, because most of the time you don't need the voice recording. So how can we judiciously use the data? We need to allow human-machine teamwork. So, you know, I showed one way, active learning, through which we're getting human input. Maybe there are other ways. The active learning is a very offline way. Is there maybe something more in time that we can explore? Visualizations, because again, ultimately we don't really care about the data, right? We really care about what kind of insights we can get. So what are the visualizations that are really going to show you the safety issues, the unwholesome trends, et cetera? And then the learning from all operations. So, you know, I think that was, you know, that was actually mentioned yesterday in the morning panel, that we want to identify those many recovery actions. And in fact, through some kind of back of the envelope calculations, our human contributions to safety team figured out that for every one time that a human contributes to a safety incident, there are about 157,000 times that a human has a positive contributions to safety. We need to capture that, right? Because those are cases that the Captain Secord mentioned. Those don't rise to a safety event. So maybe it won't even be examined. That's not right. There's a lot of information, good information in that normal data about human contributions to safety, and we need to capture that and make sure any new technologies that we introduce at least don't interfere with it, but ideally help contribute to it. Or maybe if we're sure it can take on that work and let the humans, you know, do other things, reduce their workload. Then also handling multiple timescales. So, you know, when you're on the flight deck, of course, you're dealing in like seconds and minutes, but we've done things like look at data from Houston Metroplex when they had the change back in 2014. So there, of course, that redesign was done to help mitigate certain problems. You know, initially there were probably some teething troubles, you know, as people get, you know, used to things, but does the situation kind of settle down into what was intended? You know, the problems that were meant to go away, did they go away? Did new problems kind of come in? That takes months to figure out. So we want to be able to work at that kind of time scale as well. And then through all that, we do need to be able to adapt to the changing NAS, not only new entrants, but just, you know, the world changes, you know, changes in demand for aviation. Hopefully we won't see another pandemic or September 11th style incident, but if it does, you know, can we learn lessons from the past to help restart the system?
Well, that's some great stuff, Dr. Oza, and I'll tell you what, I wasn't good at math, so if you started bringing up algorithms, that's why I became a pilot, because you'd lose me on that. But, you know, I'm glad some very smart people at the NASA Research Center is helping assist this industry with this growing issue. And I think as we start to close out the panel here, I think it's it's very important to show that, you know, there's a lot of technology that's out there. It's gonna be data driven. You know, ALPA wants to play a big part in this. We're not technology scared, we're technology forward. We definitely want to be a part of the solution, but we appreciate the collaboration for all the entities that are on the stage here. And I just wanted to let you all know that I appreciate your inputs. It's great getting into meetings and seeing people that are just ready to dive in and try to fix not just today's problems, but tomorrow's problems. So it's a pleasure working with each and every one of you, and I thank you for being here. So with that, I'll turn it back to Stacy, and we will close out the panel and give everyone some time back. Enjoy the evening tonight, but thanks to my panel. Thanks for being here.
Thanks for your leadership.
Thank you.